Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is add one row to tree. So the problem statement goes like this: given the root of a binary tree and two integers value and depth, you have to add a row of nodes with value with this particular value that is given to you at the given depth. Okay, so note that the root node is at depth 1. Okay, so the root node will be at depth 1, and you can see that the adding rule is as follows. And let me describe this adding rule in my own words. So what we will be doing is, let's take the very first example, and we will discuss certain edge cases also. Actually there is one edge case that is already mentioned. For that rule is already mentioned. Okay, so let's copy that image. Okay, yeah, this image, and these are the values that are given. Depths that at which insertion is to be done is given to be 2. Value is given to be value of the nodes whose row is to be inserted. This is the row of nodes. Inserted. Okay, so value is 1. All of the nodes of this particular row will have 1 as value. So you are considering each depth row by row. So this is first row, this is second row, or you can say depth, second depth. Their depth is equal to 3. So you can say that depth 1, 2 and 3. Okay, so these are the depth levels. You have to do the insertion at this particular depth. Okay, so what you will be doing is you will be inserting a row here of nodes, and this depth will be pushed below. Okay, so this is, as you can see now, is depth 3. At depth 3, earlier it was at depth 2. Okay, so this is what you will be doing, and there is a mention that when you are at the depth level, the level you which is equal to, levels are starting from 1, you can call this level also. So when you are at a level which is equal to depth plus 1, the given depth at which insertion is to be done, so insertion depth you can say, when you are 1 above the insertion depth, then for each node at that depth, at what depth? At depth minus 1, or okay, you can say that this level, you will do the following. First of all, you will take 2 nodes. Okay, for each node, let's say there are certain nodes at depth minus 1 level. Okay, so these are the nodes at depth minus 1 level. Okay, and for each of these nodes, you will have 2 nodes attached to it. So let's say there are certain nodes. Okay, so for each of these nodes you will do something like this. Okay, you will attach these 2 nodes to each of these nodes. Okay, and if let's say earlier the case would have been something like this, that these 4 nodes were having some children also. Okay, let's say there were some children of these nodes. Okay, like this. Okay, let's say at this particular level, this was your depth -1 level, and these nodes were having some children also, but when you replaced their children with these yellow nodes, which are compulsory to be 2 in number, one for left child and one for right child of this depth -1 level. Okay, what you have to do is you have to take their children and make it to point to their new parents. So these yellow ones will be the new parents. So if there was a left child present for the current node, then you will give that left child to the current left child of this node. Okay, so the current left child of this node is this yellow one, and since left child was present before this yellow one was attached, so you will give that child to this parent, yellow parent. And similarly right child was also present, so you will see what is the right child of the current parent, current node. This is the current node, so it yellow one is the current right child, so you will give earlier right child to this yellow. Okay, so you will distribute these children in this fashion, and here you can see that only right child was there, so you will give only right child. Here you can see only left child was there, so you will give only left child. Here both of the children were present, so you will give both of them. Okay, so you can observe the similar pattern here also, that earlier this 4 was at depth -1. Okay, depth was 2 and it was at 1. Okay, so you decided to attach 2 yellow nodes to this 4. Okay, in this fashion. Okay, and since earlier before this attaching happened, 4 was having a left child and right child both, so you will give that left child and right child separately to the new left and right childs of 4. Okay, so this is what you have to do. And there is edge case that is mentioned, that if let's say the depth level is given to be 1, okay, in that case there will be no depth level previous to it. In that case what you have to do is you have to make a node, single node. Okay, and this will be your root node, new root node. Let's say this is 1, and you will attach the current root as its left child. Okay, and all the tree will continue, and you will return this as root, new root. Okay, so this is what you have to do. You can also read the problem statement also if you want. I have described you the exact procedure that is mentioned here. Given the integer depth for each node, not null tree node, current, for each of these nodes that we were talking. Okay, these are not null nodes at depth level -1. Okay, so at depth -1, create 2 tree nodes with value as mentioned as current left subtree and right subtree. Okay, this is what we are doing, attaching 2 nodes with each of these nodes at depth -1. Okay, so this is that step. And then it is saying that current's original left subtree should be the left subtree of the new left subtree root. Okay, so if there was a left child of current, you will give it to current's new left child, which was this 0 node. Okay, and this is the third step that is happening. Okay, this is together entirely you can say the third step that we did. And this is that edge case, that if depth at which insertion is to be done is the very first depth level, then in that case there is no depth before it, then you will create a tree node with a single tree node with the value as mentioned, and make it the new root of the whole original tree, and whatever was the previous root, that will be the new root's left subtree. Okay, so that is that case that I covered in the very end. Okay, creating a single node and making it root, and making earlier root as its left child. Okay, this was the case in which your depth will be given as at which insertion is to be done is as 1. Okay, so there will be no depth before it, since depth level is starting from 1 as mentioned in the problem statement. Okay, so this is the whole thing that you have to do in the question, and or you can say problem statement. So right now you have to implement the whole thing. As you must have guessed by this pictorial representation, or the way that we were approaching also, we will be processing tree level by level. Okay, so processing tree level by level to arrive at uh, depth minus 1. Okay, so the goal is to arrive at this level. After that, there is, you can terminate the whole process. In code actually I have continued it, we can terminate it and do some optimization there. We will arrive at that, but you will do level by level traversal. So there is a prerequisite that you should be knowing how to do a level order traversal, okay, of a binary tree. Those of you who are new to this thing, I will be providing link of an article describing how this thing works out. Okay, so basically this is the article whose link will be provided to you. Level order traversal, it's like layer 1, layer 2. Okay, so this was the first layer, then this second layer, then this third layer. Layer by layer you are traversing. The whole logic, code and everything is given to you in detail here, so please check it out if you are not familiar with it. Now assuming that you have you are already knowing, or you have visited that link and learned what level order traversal is and how it works, now we will proceed further and discuss how the logic is being implemented. Okay, for that let me quickly take that code to the board and the first example also, so that you will be able to see how things are approaching there or working out as per the code and the logic that we have developed. Okay, so this is the whole logic, and before moving it to the board, I think I should be terminating here, since if we are at this particular level, then there is no need to proceed further. We can very well break things right now, and this will also not be required. I think this should work just fine. Yeah, it's working. I will tell you what I did just right now. So but it's giving wrong answer somehow. Anyways, let's continue with our previous approach only. So I don't know how, actually I am trying to make it a little more optimized, but I think I will be doing it after the video. Anyways, let's keep everything as it is. Okay, yeah, there must be a certain case that I must be missing, that's why this wrong submission is there. Otherwise the whole logic is quite fine. I was trying to optimize it. Anyways, let's discuss this one only. So what we did is, now I hope that you have already the knowledge, already have the knowledge of that level order traversal. So with that out of our way, let's proceed on discussing this approach. It's quite a lengthier code. I thought it will be a little manageable, you can say. Yeah, I think it should be fine right now. Okay, now the entire code is visible. So let's copy that picture also, or this first example, and see how things are proceeding. So let's copy it. So this is the whole thing that was required for me to explain it to you. So what we are doing is, this is just a, so this is just a standard DFS with some minor tweaks. The very first edge case that I or the very only test edge case that I discussed with you, that if you will have a variable current depth, if the depth given to you at which insertion is to be done is 1, then you will follow this procedure. Which procedure I am talking about? This one. Okay, so you will make a new root whose value will be the value that is provided to you in the input, and you will make the previous root as the left child of this new root, and you will return this new root. Okay, that is that case. If this case is not there, then you will proceed further. This right now is just simple BFS. I will tell you how things are working out, or level order, you can say. First of all, you will have a queue. You will call it level queue. Initially you will push the very first node, which is 4 right now, into the queue. This will make your first level, or level 1, or you can say depth 1. Okay, so then you will be seeing what is the size of the current level. Okay, size of the current level will be stored in this variable size, this variable. Okay, and you will do this entire thing till your queue becomes empty. Okay, so right now we will be searching, if we will be checking if the current level that we are visiting is equal to depth minus 1 or not. Okay, so we will have a current depth variable. With each depth that we are visiting, we will increment the current depth. So right now current depth will be at here, at this particular point it will be 1, at this particular point it will be 2, at this point it will be 3. Okay, so you are checking for depth minus 1. So depth is given to be 2 here, and your value is 1. Okay, so what you will be doing is, when you are at depth minus 1, which is 1 by the way, so when you are at this particular depth, you will be making two node copies, or new nodes for each of the nodes in this particular row or level. Okay, there is only one node, so you will be entering this condition, and you will be making two nodes, new nodes, left new and right new. So this is your left new, and this is your right new. Okay, now what you will do, before attaching these nodes to 4, before making these two links, what you will do, you will make these two links. Okay, so you will see whether 4 is having left and right child. Okay, yes, it is having. So you will add its left child to left new and right child to right new, which was earlier left and right childs of 4. So you can say that earlier left child of 4, and similarly it was earlier right child of, or previous right child of 4. So you will distribute them to left and right new, form these links. So this is step 1, and then you will make these links. This is step 2. Okay, so this is what we are doing here. If 4 is having a left child, then you will give it to left new. If and you will attach your left new to your current node, which is 4, by the way. This is your current node. Okay, and if your current node, or let's say 4, is having a right child also, then you will do similar thing for right child. First of all, make this link, which is what we are doing here, and then we will form this link. Okay, this is what we are doing here, and then the whole thing is just simple BFS traversal. This is the case in which we are not at depth -1 level. Whole thing will continue and you will be returning your root. Okay, so now talking about what will be the time complexity and this kind of space complexity things. So you can very well see that it will be order of so as far as time complexity is concerned, it will be order of n, where n is the number of nodes, because you know we are visiting each node that is given to us in this tree only once, so that is why. And if we consider what will be the space complexity, then it will be the maximum number of nodes present in a row, or maximum number of nodes in a level. Okay, nodes in a level will be the space complexity. Order of this, okay, will be space complexity. So these will be the complexities. If you are still having any doubts or any queries in general, then you may ask them in the comment section. And I hope this video and this problem solving session provided some or added some value to your journey of owning your DSA skills. And please remember that consistent practice is the only way to master DSA. And stay tuned for tomorrow's challenge, and I will see you in the next video. Thank you for watching.